Another financial function is rate function. Now with this function, we can calculate the rate. As you have noticed so far, the rate was always a parameter. It was given. Now we are going to actually calculate the rate function using rate function. The example is you want to borrow $80,000 and make monthly payments for 10 years. The maximum monthly payment you can afford is $1,000. What is the maximum interest rate that you can afford? So with this example, you know how much you can afford, you know how much you're borrowing, you know that you're going to be making monthly payments for a given period of time. But what you don't know or you have not been provided with or given is the rate that you can actually afford, given you may be offered with different options. So we are going to use the rate function. There are 5 arguments: number of periods or payments, PMT, which is the payment, PV present value, future value, and type. Type is 0 when we make payments at the end of the month. So in this example, we are making monthly payments and it says for 10 years. So we have learned that we will look at the time unit in the payments, which is in this case month. And we are going to be making payments for 10 years. So the first argument in the rate function, which is number of periods or payments, that's the total number of time units, which would be 10 years multiplied by 12, because we are making monthly payments. That would be 120 payments. The payment is $1,000 a month. As it is a payment, it goes in with the negative sign. The present value is how much you're borrowing. It's 80,000. You note that it does not go in with a negative sign because you have not made a payment of $80,000. You have actually received $80,000. The payment that you have made is $1,000 a month. So that goes in with minus 1,000. What you're receiving is 80,000. Future value is 0 and type is 0 as well. So let's take that to our Excel file. We have equal rate, number of periods or payments, which was 120. We have payment, which is $1,000, so that's minus 1,000. How much we are loaning? 80,000. This goes in as positive because it is not a payment. And type is 0, so we would not need to input that. And we get 1%, which is actually different than what we find in the PowerPoint slides, which is 0.7241%. Now this percentage is going to be monthly because we are doing monthly calculations. The time unit in these arguments are monthly. 120 month or payments, $1,000 monthly payment. We are loaning 80,000 and we are going to make payments at the end of the month. So the rate we are receiving is monthly. The question is why we got 1% in Excel, and which I got 1%, and it is likely that you're also going to get 1% when you follow this process. But the real answer is 7241. It is really about the formatting of numbers, which we are going to study later, but as we are on it, we will look into the number group in the Home tab. So we are in the Home tab, number group. At the corner here, there is an arrow with 45 degrees pointing to the bottom, right? So if you make a left click on that, this box will pop up. Now here, you will see different formatting for numbers. One of them is actually percentage, because what we're expecting as the result or outcome of using rate function is a percentage. So the formatting for the number will be percentage. There are different formattings that we'll look at. For this example, we are interested in percentage because it's rate. Now, the decimal place is a 0. So we would like to increase that to 4. And as you see, as I am increasing the number of decimal numbers, the number here is actually changing. So when you only put like 0 decimal numbers, it's likely that it's going to round up the number. So you can put like 4 or 5. So you see that it becomes 0 in the 5th decimal number, meaning that, you know, there's no difference between now 4 decimal numbers and 5 decimal numbers, given that the 5th decimal number is actually a 0. So we can just go with 4, and if you press OK, now you're going to see the actual monthly interest rate. If you're interested in finding the annual rate, you can create a formula. You can say equal, then make a left click on it and multiply it by 12. So if you do your calculations monthly, but at the end they give you an annual rate that you want to know if you can afford that or not. So you're looking at 8.68% yearly, or 0.7241% monthly. So that would be the maximum interest rate that you can afford given these payments, the duration or the length of making the payments, as well as how much you're going to borrow. Another financial function in Excel is to calculate or determine the number of periods or payments. Again, as you have noticed, it is one of the parameters that we are usually provided with, but we can actually calculate it. In other words, it can actually be an unknown variable. Now, to find the number of periods or number of payments, we will use MPER function. So let's look at an example, and there are 2 scenarios that I have developed for using MPER function. If you borrow 100,000 at 8% and make payments of 10,000 per year, how many years it will take you to pay back the loan? So we know the rate, we know how much you have borrowed, and we know how much payment you're making. And the question is how much time it's going to take to pay back the loan. So we have equal MPER, the rate is 8%. The payments you are making are 10,000. It's a payment, so it goes in as negative. The present value is how much you're borrowing, which is 100,000. The future value and type are both 0. So let's take that to Excel. We have equal MPER. The rate is 8%. You're making payments of 10,000, so that would be minus 10,000, and present value would be 100,000. Close parentheses and press enter. It would be 20.91 years, which is the number of periods. Now, in the second scenario, there's going to be a payback or a total lump sum payment at the end, which that is going to affect the type in this syntax. So we have 5 arguments. One of them is type. And in the second scenario, this type is going to be affected, or it's going to assume a value. So if you borrow 100,000 at 8% and make payments of 10,000 per year, how many years it will take you to pay back the loan, supposing you're planning to pay back 40,000, and that's basically at the end. So as like before getting into the calculation, you can expect for a shorter length of time in paying back the loan, given that you're going to make a total lump sum payment at the end. But what that is, we are going to calculate that. So everything is like scenario 1. The only thing that has changed is how much at the end you're going to pay back, and that is 40,000. So if we take that to Excel, we have equal MPER. The rate is 8%. You're making payments of 10,000. The loan is 100,000. And the future value, that is how much you're going to be paying, or how much is going to be outstanding. So you have 40,000, but it's actually a payment. So that will go in as minus 40,000. Now close parentheses. As it's a payment, that went in with a negative sign, you get 15.90 years, and that is how much time it's going to take to pay back this loan. The last part of this chapter, it's on depreciation. So depreciation is the loss of value in an asset, or it's the reduction in the long-lived assets from use. Basically, you use an item, it depreciates in value as time goes on. There are different formulas for calculating depreciation. As I've mentioned, I think it's a topic that is discussed in the accounting discipline. Engineers will discuss this in their engineering economics course. It could be a topic to be discussed in the finance class. Here, we are learning how you can use Excel and the financial functions in Excel to calculate depreciation. So the first thing is to understand what depreciation is, which is the assets lose value when you're using them. For example, a machine. So you buy a machine, you buy a car, you buy a printer, you buy an equipment. When you use it, it is depreciated. And at the end, there might be salvage value for that particular machine or equipment. Salvage value is when you go to sell that equipment or machine, how much it's actually worth or how much you can sell it for. Maybe you buy a car for $10,000, you use it for 20 years, maybe the car is not working the way it used to work, or you would like to sell it. Now there's going to be, or there might be some value to that car after 20 years that you want to sell it. Whatever that value is will be the salvage value. Now knowing that, let's get into calculating depreciation. There are different formulas for calculating depreciation. We're going to look at two of them. One is straight line depreciation, or SLN, and basically that SLN is also the function in Excel. With the straight line depreciation, we are assuming that the amount that an equipment or a machine is depreciated is the same amount across all years. So for example, if you're going to buy an equipment and use it for 20 years, the amount of depreciation in year 2 is equal to year 3, is equal to year 4, is equal to year 10, is equal to year 20. So the total depreciation is uniformly distributed across all years, meaning that the depreciation amount in each year is the same as the other year. So that's called straight line depreciation. The total depreciation is uniformly distributed across all years, meaning that the depreciation amount in each year is equal to other years. The second approach to calculate depreciation is sum of years digits depreciation, which is SYD, and that's actually the function in Excel which is used to calculate depreciation. Now with this function, the assumption is that you will depreciate less as time goes on. So more depreciation happens in the beginning years than later. So let's look at an example, and then we will take that to Excel and use these functions. Let's consider a new machine that is worth 15,000 and over 5 years will be depreciated to a final or salvage value of 3,000. What that means is that it's worth 15,000 in the beginning. After 5 years, it is worth 3,000. So basically, it has lost value in the course of 5 years of being used. The question is how much it has lost value. In other words, how much it has been depreciated. That is 15,000 minus 3,000, which is 12,000. So it has lost value equal to 12,000. Now we say straight line depreciation, that in that formula, the total amount of depreciation is uniformly distributed across all years. That means from 15,000 to 3,000, there's total amount of $12,000 depreciation over 5 years. So if you do 12,000 divided by 5, you get $2,400 a year. So in year 1, it is depreciated for the value of 2,400, and that's the same in year 2, 3, 4, and 5 for a total of 12,000. So let's just take that to Excel. So we have equal SLN, double left click on it. Now it's going to ask for the cost. So what is the cost? It is costing us 15,000. That is 15,000. The salvage value is 3,000, comma, and that's asking for life. We said that we're going to use it for 5 years. So after 5 years, the salvage value is 3,000. If you close parentheses and press enter, you get $2,400, and that's the depreciation value for every year. Now let's try the other formula. In the other formula, which is SYD, we said that it depreciates more in the beginning years than later years. So as time goes on, it is still depreciates, but depreciates less than how much it depreciated the year before. So that is, you're going to have a different depreciation value for a year. So if we want to use the SYD formula or function, the cost is 15,000, salvage is 3,000, life is 5 years, right? Now it's asking for per, and that's the last argument. That's basically in what year you want to calculate the depreciation value. So I'm going to put 1, close parentheses, I get 4,000. Now you can do this again. You can put equal SYD. The cost is 15,000. Salvage is 3,000. Life is 5. Now you want year 2. You want to know the depreciation value in year 2. Close parentheses, press enter, you get 3,200. What if this was a machine that is going to work for 30 years and you have a different depreciation amount in each year? You would not want to do this calculation like 30 years for like 30 times. We have learned that we can actually copy formulas. So that's exactly what we can apply here. We can type year, and we have 1, 2, 3, 4, and 5. So we have got basically 5 years to be used in the calculation for depreciation. So depreciation, I'm going to put DP, and equal, we are using SYD. What is the cost? 15,000. Salvage is 3,000. Life is 5. And then rather than typing 1, we can just click on 1. So I just made a left click in this cell, which is 1. And that is, we want depreciation in year 1. Now close parentheses, press enter. Now all we have to do is to make it left click on this cell, and then in the corner, you see that little green box. So if you make now if you hover around that green box, you see this black summation symbol. If you make a left click on that, hold on to it, drag it down, it's going to give you the depreciation amount across all 5 years. Now let's check something. The question is, what is the total amount of depreciation? So that would be how much it depreciated in year 1, plus in year 2, plus in year 3, plus in year 4, and plus in year 5. So if you select all these 5 cells, you see at the bottom here that the summation is 12,000. So the total amount of depreciation is 12,000. As you see, with SYD, it is distributed differently. It depreciates 4,000 in year 1, it depreciates 3,200 in year 2, 2,400 in year 3, 1,600 in year 4, and 800 in year 5. But the total amount of depreciation is 12,000. It is just distributed differently, depreciating more in the beginning years than later years. With the previous formula, which was a straight line depreciation, the total amount of depreciation was still 12,000, but it was uniformly distributed, meaning or assuming that the amount of depreciation in each year is equal to all the years across the life cycle of that product. And that is exactly what we have in the last PowerPoint slide here, which is we have SYD here. We have just used 1 and 2 as the years. We could have year 3, 4, and 5 here as well. But you saw that all we had to do in the Excel file was just to click on 1 rather than typing 1. We can just click on 1, and then when we drag it down, then 1 is going to be replaced by 2, then 2 is going to be replaced by 3, 3 is going to be replaced by 4, and 4 is going to be replaced by 5 when we drag it down to calculate depreciation. And by doing that, we are basically using what we have learned as copying formulas, because there are examples that you may want to use, a machine for 30 years, and all you have to do is just drag it down, and then you will get the depreciation amount for every single year.